Welcome back, everybody. Today's video is about fossils and what we can learn from them. You're going to be taking notes in your Topic 7 note packets starting on page 5. In addition to being really cool in their own right, fossils are important to study because they can tell us a lot about what life used to be like on Earth. Take these guys for example. They're not just a bunch of dead fish, they're evidence that ocean life must have been flourishing in a place where it no longer is. So write this down in your notes. Fossils are the preserved remains of past plant and animal life. And they can tell us a lot about how life has evolved on Earth and what past environments were like. There are a few ways that fossils can form. Here's one of the more common methods. Here we are in a marine environment, and this poor little fella is passing away. Sorry, don't want to bum anyone out, but it does happen. After this animal decomposes, deposition causes its remains to be buried. When those sediments are compacted and cemented, they turn into sedimentary rock, and those remains become part of the rock. Later on, geologic processes can force those rocks to the Earth's surface, and we find our fossils. If you'll refer back to your notes, you'll see there actually are 3 types of fossils. Sometimes parts of the plant or animal are preserved. Other times, molds or casts are preserved, and those are imprints of the plant or animal. And other times we might find these things called trace fossils. These are evidence of the daily life of these animals, maybe a footprint or a nest or some scat. Scat, by the way, is poop. Some fossils can be used as time markers and to match up rock units from different locations. We call these fossils index fossils. To better illustrate index fossils, we're going to play a little game called Name This Time Period. If you guessed from the terrible hairstyles, clothing, and music that this was the 80s, you are correct. Now, I know some people still like to rock that mullet cut, but these are really things that are all from the 1980s, so when you see them, you know what era we're talking about. These are all kind of fossils in their own right, but trust me, kids, some things really just need to stay in the past. But you could think of these as index fossils for the 1980s. So as we're going to see, index fossils are the remains of animals or plants that only lived during very specific time periods. So when we find them in a geologic sequence, we know when that rock was formed. So in this geologic cross-section, you can see in all those layers of sedimentary rock, we have a lot of fossils. And not all of them can actually be used for index fossils because a good index fossil is going to have a couple qualities to it. So here's our fossil. If we want to use him for an index fossil, first, he needs to have lived over a large area, so he needs some friends. Second, these guys only lived for a short period of time. So let's say a terrible catastrophe befalls all these little fellas and they all die. All those little carcasses are deposited in the mud. Then more sediments are deposited on top. They're all compacted and cemented together, and you get layers of sedimentary rock. Then let's say the ocean evaporates, and crustal uplift forces those fossils and all the surrounding rock layers upward. Now that all these rocks are exposed at the surface, they can undergo weathering and erosion. Now I want you to notice something. Because these little guys only live for a short period of time, they're only found in one layer of that rock. But you can find that same layer of rock in lots of different places. So if you ever find these little guys in a rock and you know how long ago they lived, you know how old the rock is. You can also use these fellas to correlate or match up rock layers from different places. If you find the same index fossil in the same type of rock, in 2 different locations, it must be the same layer of rock that's missing in the middle. So let's go back to your notes. Write this down. Index fossils. Fossils that are used to define geologic time periods and define the age of the rocks that they are found in. They were alive during specific geologic time periods. And a good index fossil has two qualities. One, it lived for a short time. And two, it lived over a broad area. Next in your notes, you'll see a geologic cross-section, and it has a lot of fossils in it. I want you to try to figure out which of those fossils would make a good index fossil. How about this guy? He's found in a lot of layers of rock, but also over a big area. You can find him in a lot of places. Think he'd make a good index fossil? No, because he's found in a lot of different layers. That means he lived for a very long time over several time periods. That's good for him, but not for us. How about this guy? No, same problem. He's found in multiple layers. Now how about this guy? He's found in a lot of places, but only in one layer of rock. Notice it's the same layer of rock, just found in different locations. This guy could be used as an index fossil. So can this guy. Only found in one layer, but that same layer's in different places. Even though it's missing in some spots in between, you can use him to actually correlate those locations. And you can see that these are actually one layer of rock that's been eroded away in the middle. There are a lot of index fossils found in New York that we can use to correlate rock layers across the state. And, as always, you can find a lot of this stuff in your reference tables. On pages 8 and 9, you'll find the geologic timeline, and along the bottom of those pages, you will find index fossils. Notice that each one has a letter that goes along with it. Each of these guys was alive during a very specific time period in New York. To find out when, first you want to find the letter that corresponds with this little guy. Then you want to find that letter under the time distribution of fossils column. When you scan down through this column, notice that each letter is in a specific row. Each row represents a different geologic time period. So for practice, let's start with this little guy, Hexameroceras. Notice he's represented by letter E on the chart. So what we would do is we would go to the time distribution fossils column when we would find letter E. Notice E is on this vertical line labeled nautiloids. That's the fossil group that this guy belongs to. To find the time period that he's from, you simply go to the left and look under the period column, and you will see that this guy is from the Silurian time period. To find a place in New York where these guys might be located, you want to go to page 3 in your reference tables. Remember, our index fossil was from the Silurian time period. So if you find Silurian in the key, you'll see a map symbol there. That map symbol represents Silurian bedrock and where we can find it in New York. And you'll find this bedrock stretching across upstate New York, right in this area. So within that area, you'll find the same fossils from the same time period because they're all formed at the same time.